Welcome back, everyone. We're going to be solving LeetCode 2181, merge nodes in between zeros. So we're given the head of a linked list, which contains a series of integers separated by zeros. The beginning and end of the linked list will have a node value equal to 0. For every 2 consecutive zeros, we need to merge all the nodes lying in between them into a single node whose value is the sum of all the merged nodes. So we take a look at example 1. They give us the list 031045520, and we want to output a list of 411, right? So if we take a look here, there are 2 nodes in between the first set of zeros. Those 2 nodes are 3 and 1. The summation of both of those nodes is going to be 4, and likewise for the last 3 nodes, the summation is going to be 11. So how can we solve this? Well, we're going to have to loop through, and we can do this in one pass. We're going to have 2 pointers, a left pointer and a right pointer, and we will just loop through our list and gradually increment our right pointer until it hits a 0, and then we'll just sum the nodes up and set the last, or the left pointer, I should say, the next value equal to the summation that we have, and then we can just set that next node's next pointer equal to our right pointer and continue down the list. And it'll make more sense when I show you. So let's just do this. We'll say our left pointer is going to be equal to our head, and our right pointer is going to be equal to the head.next value. We're also going to have a running summation. We'll initially set that equal to 0. And what we want to do is loop through this list while our current right pointer is not none. And we want to do 2 things. We want to do something if our current right pointer, if the value is not equal to 0, and if the value is equal to 0. So we'll say if the current right pointer .val is not equal to 0, what do we want to do? We just want to say increment the running sum plus equals by the current right.val, and then we can increment the current right pointer by 1, so current right.next. Okay, now we need to handle the case where our right pointer value is equal to 0. If it is, what do we need to do? Well, we need to set the left pointer's .next value equal to the running sum. That's the first thing we should do. So we'll say current left .next .val is going to equal the running sum. Then we can say the current left node should now be pointing to our right node, right? So current left dot next should now equal the current right node. We also should reset our running sum. Running sum should be equal to 0 now, and we also want to increment our current right pointer by 1. Current right is going to be equal to current right dot next, and we should also, before we set our current left pointer's .next value equal to our current right, if we did this before incrementing our current left pointer to the value that we just incremented, we would end up deleting this node. So we will have to increment our current left by 1 beforehand. So current left is going to be equal to current left dot next, and then we can set the current left dot next pointer equal to our right, reset the running sum, and increment our current right pointer by 1. So let's print out the head value now just to see what we're working with. So now we have 0, 4, 11, and 0, right? So that's obviously not what we want. We want 4 and 11. So how do we get rid of the ending zeros? Well, in order to get rid of the first, right, the head 0, we can just return head.next, right? That'll give us 4, 11, and 0, but how do we get rid of the last 0? Well, once we've gone through this loop if we print out the current left pointer, let's see what that gives us. The current left pointer gives us 11 and 0. So if we just set the current left pointer's .next value to none, that'll eliminate this ending 0. So after we run this while loop, we should do current left.next is going to now be set to none, and that'll get rid of the ending 0. So let's run this. This should work now. And it does. We pass both test cases, so we'll submit. Perfect. So time and space complexity. Time complexity is going to be O of n. We are doing this in one pass. And the space complexity is going to be O of 1. We are not creating any new data structures to solve this problem. So that'll do it for LeetCode 2181.